So far, we've just looked at multiplying a number by a binomial, a number by a trinomial, or a number by a polynomial. Now what we're going to look at is multiplying two binomials together, and then multiplying binomials and polynomials. The rule is that everything in one bracket needs to get multiplied by everything in the second bracket. So we have a way to remember that, an acronym called FOIL, which stands for first, so first term in each bracket, outer, so the outside terms, first, outer, then we have the inside terms, and then we have the last terms. So let me write it up here. So we've got FOIL as an acronym to help make sure we multiply everything together. So first, outer, inner, and last, which is one way, and I'll show you a different way on the next example. So our first terms would be x times x. Our outer terms would be x times 4. Our inner terms would be minus 2 times x. And then we have our last terms, which would be minus 2 times 4. So simplifying that, we get x squared plus 4x minus 2x minus 8. I notice that my two terms in the middle are like terms, and I can combine those together to give me x squared plus 2x minus 8. Now my second example, I'm also multiplying binomials together. So here I'm going to show you a face. So this is the multiplying polynomials guy. We've got some eyebrows. The brackets represent his eyes here, or her eyes, or their eyes. Then we have a nose right here between the two inside terms. And then finally, we have a mouth. So those are two different ways to help you to remember which terms to multiply together. So again, my first eyebrow would be m times m. My second eyebrow would be m times minus 5. My nose would be minus 3 times m. And then my last terms are going to be my, let's see, I've got plus minus 3 times minus 5. Expanding those all out, I get m squared minus 5m minus 3m plus 15. Again, my two middle terms are the same. I can simplify those to m squared minus 8m plus 15. Okay, two more binomials. First times the first, outer, inner, last. So we've got 2x times 7x. Let's just rewrite that. So 2x times 7x will give me 14x squared. 2x times minus 1 will give me minus 2x. 9 times 7 will give me plus 63x. And then 9 minus 1 will give me minus 9. My two terms are like terms. I can combine those to finish simplifying my answer. Would give me plus 61x. Now here is example D. Is not like the first three that I've done because there is a minus sign in between the two terms. This is using the distributive property to expand and simplify. So that minus sign needs to be distributed in to the second set of brackets. But you do not multiply the binomials together in this case because they are separated by a subtraction sign. I can simplify my like terms. 2x minus 7x is minus 5x. 9 and 1 is 10. Example E is another example of multiplying binomials together. The next two you might want to pause the video, try on your own, and then check to see if you got the correct answer. first, outer, inner, last. 2m times 3m is 6m squared. 2m times minus 1 is minus 2m. 3 times 3m is plus 9m. 3 times minus 1 is minus 3. Combining my two inside terms, 6m squared plus 7m minus 3. Example F, first, outer, inner, last. Notice that these brackets are almost the same except for the sign in the middle. 3c times 3c is 9c squared. 3c times minus 4 is minus 12c. 4 times 3c is plus 12c. 4 times minus 4 is minus 16. My two middle terms are the same, and when I add them together, they actually add to 0. So all I'm left with is 9c squared minus 16. So that is a special pattern that happens when you have two binomials that look like this. Now we're going to expand some binomials that are written in a different form to start off with. I have x plus 3 all squared. It is tempting to do this, like we were doing before, and end up with x squared plus 9. However, this is not a binomial inside the bracket, so the best way to visualize this is the base, that x plus 3, multiplied by itself the number of times that is in the exponent. So this is twice. Now it looks like the examples above. I can do my first, outer, inner, last. X squared plus 3x plus 3x plus 9, which simplifies to x squared plus 6x plus 9. Now you've seen one example of those types. You might want to pause the video, try the next two on your own, and then check to see if you get the right answer. I'm going to expand my first expression to be m minus 2, so I don't forget the middle terms. Then I'm going to expand using FOIL. First, outer, inner, last, m squared minus 2m minus 2m plus 4. Simplifying that to m squared minus 4m plus 4. So similar pattern as example G. And we're going to look at one more. 5y minus 3 all squared. I'm going to rewrite that as 5y minus 3 times 5y minus 3. And then I'm going to use FOIL. First, outer, inner, last gives me 25y squared minus 15y minus 15y plus 9, which I can simplify to 25y squared minus 30y plus 9. My last two examples are a little bit different. They've got an extra wrinkle thrown in. K looks almost like examples G, H, and I, except there's a 2. So I'm going to expand my exponent. And then I'm going to use FOIL to expand the binomials. And then I'm finally going to multiply everything by 2. So first, outer, inner, last, x squared plus 5x plus 5x plus 25 simplifies to 2 times x squared plus 10x plus 25. And now I'm going to distribute again, multiplying everything by 2. 2x squared plus 20x plus 50. My last example, I have a binomial times a trinomial. FOIL doesn't really work here, but what I'm going to do is take each term in my first bracket and multiply it by each term in the second bracket. So this one I'll write out so you can see all the multiplications. So x times 2x squared, ooh, plus x times minus 3x plus x times 1. And then I'm going to move on to my second term in the first bracket, minus 3 times 2x squared plus minus 3 times minus 3x plus minus 3 times plus 1. And then I'm going to complete all those multiplications. So 2x cubed minus 3x squared plus x minus 6x squared plus 9x minus 3. And then I'm going to identify my like terms. So I have x squared and x squared. I have x and x. And then I have a 2x cubed at the beginning. 6x squared next. Oh, that's not true. I have minus 9x squared. And then I have 10x minus 3 as my final answer. Those are some examples of multiplying binomials together, an extension of the distributive property.